Bacteria are everywhere, literally everywhere. In fact, there are more bacterial cells in our body than there are human cells. Luckily for us though, most of the bacteria, most of the time in our body, is good bacteria, the ones that live in your gut and keep you healthy. However, you can become infected by bacteria that make you sick. And there's a spectrum to this. Sometimes the bacteria might just make you feel a bit lousy for a few days. Other times, you could be in a life-threatening condition. Most of us know, or most of us will have experienced, that when you have a bacterial infection, you get prescribed antibiotics. However, as a society, we're currently experiencing an antibiotic resistance crisis. Antibiotic resistance is when bacteria become resistant to some, or even all, of the antibiotics we have available in hospitals and GP clinics. Even if you have never, ever taken an antibiotic in your life, you can still be infected with bacteria that are resistant to antibiotics. This means that antibiotic resistance has the potential to affect anyone of any age in any country. That means me, you, your granny's friends, the person you met on holiday when you were 12 and you still write to, anyone. And that's a really sobering thought. So what do you do if you have an antibiotic resistant infection? Well, first of all, you hope that it's not resistant to all antibiotics, and you then try and find as quickly as possible an antibiotic that will work. But if you do have an infection that's resistant to all antibiotics, well, all we currently have is hope and your own body's immune system, which you hope will be able to fight off the infection. This is where I step in as a microbiologist. So I am trying to develop new antibiotics to try and overcome the crisis of antibiotic resistance. I've discovered a new protein antibiotic that works extremely well in a bacterium called Pseudomonas aeruginosa. And this bacteria is particularly problematic for people with cystic fibrosis. So I've discovered this antibiotic and I know it works really well, but I don't know how it works. I know that it can kill the bacteria, but does it get inside the bacteria? If it does, what does it do once it's inside? How does it actually work on the bacteria? And the reason I want to know the answer to this is because, firstly, if I can figure out how the antibiotic works, then it's more likely to be approved for human use in the future. And secondly, if I know how the antibiotic works, I can try and develop similar antibiotics that may work even better and that may have more desirable properties for turning this antibiotic into an actual medicine.